All right, in homework 11.6, we were putting it all together. We go over a couple of these, make sure we know what's going on. The first thing we need to be able to do is graph polynomials. And our first step in graphing them is to make sure we know what the different things we need to get right are. You do not know everything about polynomials, and there's no way to in Algebra 2. There are certain things we won't get to until calculus. But what we should make sure we have right is the x-intercepts, the y-intercepts, the in-behavior. So for instance, we can already tell at the very beginning that this has a y-intercept of 6. We can tell that because it's a cubic, the ends have to face opposite directions, and because the leading coefficient is positive, we know that it'll be going down to the left and up to the right. So we'll fill that in a minute and make sure that's correct. The last thing we need is the zeros, and to do that, we're going to need to factor this. The very first thing we need to do to factor is we need to factor out any common factors. And there are a couple of special things we look for. If there are ever any fractions, we're going to factor out the fraction denominator. If it ever starts with a negative leading coefficient, we're going to factor out a negative. And if they ever all have an x with them, we're going to factor out that x. So in this case, there's no actual common number that's multiplying times all of these, but there is a fraction, so it's one of our special things. And so we need to factor out that fraction. So we're going to rewrite this as f of x equals 1/3 times, we're dividing everything by 1/3, which is the same as multiplying everything by 3. So this is going to be x cubed. When we multiply this one by 3, it's just minus 2x squared. When we multiply this one by 3, it's minus 9x plus 18. And we know this is right because if we multiplied by 1/3, it would give us the right thing. And this is now a much easier thing to factor. So we're going to continue factoring. And our next step is, because it's a cubic, we're going to need to use long division. We don't want to just be blundering around and trying all sorts of different things for long division, because that would take forever. Our first step here is going to be to find a 0. So I'm just going to plug in different numbers for x until I get one that equals 0. I'm going to try 1. 1 cubed minus 2 times 1 squared minus 9 times 1 plus 18. 1s are really easy because it's just the coefficients. 1 minus 2 minus 9 plus 18. But this is not equal to 0. This is equal to 8. So 1 is not a 0. And that means x minus 1 is not a factor because 1 doesn't go into it. I'm going to do the same thing for 2. 2 cubed is 8. Minus 2 times 2 squared is 8. Minus 9 times 2 is 18 plus 18. 8 minus 8 is 0. Minus 18 plus 18 is 0. And so x equals 2 is a 0. Since x equals 2 is a 0, we know that x minus 2 must be a factor. So I'm going to do x minus 2 and divide it into x cubed minus 2x squared minus 9x plus 18. Now, I could have divided it into this original one with fractions, but it would be a lot harder. So what we're doing is we're factoring this inside part. We'll leave the 1/3, but we're factoring this. We're going to see x minus 2 times what gives us this. So let's remember how to do long division. X goes into x cubed, x squared times. X squared is going to multiply times this binomial. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And when we subtract, x cubed minus x cubed is 0. Here we're subtracting a negative. Minus a negative is adding. So it's negative 2x squared plus 2x squared, which is 0. So we bring everything else down. Obviously, x doesn't go into 0, so we're not going to have any x terms. X goes into negative 9x, negative 9 times. Negative 9 times x is negative 9x. Negative 9 times negative 2. Oops, that was plus 18. I didn't write down the problem right from up here. So plus 18, plus 18. Negative 9 times negative 2 is plus 18. And when we subtract, we're subtracting a negative. So it's plus 9x. That's 0. 18 minus 18 is 0. And so it came out with no remainder, which we knew it would, because otherwise x equals 2 wouldn't be a 0. All right, so that tells us that x minus 2 times x squared minus 9 is x cubed minus 2x squared minus 9x plus 18. So f of x is equal to, don't forget that 1/3, 1/3 times x minus 2 times x squared minus 9. Basically, we replaced this with what multiplied to make it, which are these two factors. This can still be factored more. So 1/3 x minus 2 times x plus 3 times x minus 3. Sometimes you might need to use the quadratic formula. When you get down to the quadratic, you could have real zeros, imaginary zeros, irrational zeros. There's a bunch of different possibilities. But in our case, we've got some pretty easy ones. Because x minus 2 is a factor, there's a 0 at x equals 2. 2 minus 2 is 0. X equals negative 3 is a 0 because negative 3 plus 3 is 0. So negative 3 is a 0. And positive 3 is a 0. So all I'm going to do now is I'm going to fill this in using my y-intercept and my in behavior. I know it's going down to the left. It's got to go up here. The closer together they are, the less far down it goes. You know, I could, if I wanted to get an even better graph, I could do something like plug in 1 into the function. I could plug in 1 and see what that y value is to see, you know, whether it should be coming up or going down there. And if I had done that, my graph would be just a little bit better. I could have seen that the y value at 1 was actually like right around here. And so the real graph is something more like this. But again, until you get to calculus, I don't expect you to be able to find exactly where this is. We can see, I could have asked you questions like, where is f of x increasing? And you wouldn't know exactly where it is, but you could estimate it's increasing from negative infinity to about negative 1. And it's also increasing from about 2.5 to infinity. Again, until we get to calculus, we won't be able to tell exactly where it's increasing. But we can at least estimate. All right, on the back, I'm not going to do these for you, but I will at least like make sure we understand what's going on with these tricky questions. We've got two polynomials, m of x equals this and p of x equals this. All right. For what values of b does m of b equal 3? So if m of x is this, m of b means you plug in b. So it's going to be b cubed minus 2b squared minus 16b plus 35. That's m of b. And we want to know where that equals 3. So we're going to set it up and have it equal to 3. This is a cubic equation. So for polynomial equations, we set them equal to 0, just like with quadratics. We set them equal to 0 and factor it. So you're going to need to use long division to factor this one to find it. What is the average rate of change of m of x on the interval from 0 to 2? All right. We've got this polynomial. I don't know exactly what it looks like. And we want to know what the average rate of change is between x equals 0 and x equals 2. And what the average rate of change is the slope of the secant line, the slope of the linear function connecting those two values. That's y2 minus y1 over x2 minus x1 from algebra 1. Or sometimes we'll call it, I guess we should call it m of 2 minus m of 0 divided by 2 minus 0. This is our second y value minus our first y value. Here's our second x value minus our first x value. So you don't actually have to graph it. You just need to say, well, what was the y value at x equals 0? And the y value was 35. So we've got this point 0, 35. That's x1, y1. And at x equals 2, let's plug it in. 2 cubed is 8. I'm just plugging in 2 into x, m of 2. Minus 8 minus 32 plus 35. And that's 3. When x is 2, m of x is 3. And so, you know, what we have here is at, what this looks like on a graph is at 0, you're at 35, and at 2, the y value is down to 3. And so the rate of change is going to be negative because m of x, oh, you guys couldn't see that, I apologize. The rate of change here is going to be negative because m of x decreased from 35 to 3. The way we find this is y2 minus y1 over x2 minus x1, m of 2 minus m of 0, m of 2 minus m of 0 over 2 minus 0. m of 2 is 3, m of 0 was 35, 2 minus 0 is 2, so we get negative 32 over 2, which is negative 16. That's the average rate of change. There was all sorts of crazy, weird polynomial stuff. It's curved. It's not a straight line. But on average, m of x decreased by 16 for those 2 units. Went down by 16, went down by 16 again. And that's why it ended up from 35 going down to 3. Okay, so I actually did do this one for you. Dang, I said I wasn't going to. Got too excited by the math. Couldn't help it. All right, at what values of x do m of x and p of x intersect? Well, m of x and p of x will intersect when the y values are the same. And the y value is this and this. So where will the y values be the same? Well, it's going to be when these two are equal to each other. So we're just going to set these equal to each other and solve that quartic equation. I hope that helps in your homework. Good luck with the rest of it.